In order to explain our software approach, it would be beneficial to look at the LabVIEW front panel. Prior to user interaction, the left side of the panel is operated by the technician for calibration and setting the RMS threshold. In the middle, the user interacts with the alphanumeric keyboard array by contracting their biceps to control the rows and columns value. These values correspond to the array's indices and thus to a keyboard element such as a specific letter, number, or space. As the row and column changes, the current element is displayed accordingly. Thus, the message string is built one character at a time. The keyboard features fully customizable elements that can be tailored to the user's needs. The mechanics governing the keyboard and the string can be seen in the LabVIEW block diagram. The row and column are programmatically identical and were optimized by our valid input approach. When the signal from the biceps is above the RMS threshold, the program increases the value by 1, and were it to increase beyond the dimensions of the keyboard, it would automatically reset to 0. We achieved this through LabVIEW's case structures. The enter command, governed by a calf contraction, allows for character selection. Case structures allow selection to proceed to concatenating the selected element to the message. Between uses, the message remained, and so case structures were employed to reset the string. A problem was determining how to store the current values of the row, column, and string between iterations of the governing loop. Through much research, we decided on using shift registers in conjunction with the aforementioned case structures. Finally, a loop termination feature was created. When all three muscles are above the RMS threshold at the same time, the program would exit the loop and send the current string message to the text-to-speech software. We obtained from the National Instruments website this LabVIEW VI that governs the verbalization of the message. The string feeds into the LabVIEW element that pronounces the message and completes the intended purpose of this device. The user will have now effectively communicated a verbalized message.